Question 12 says AB defines a point on the terminal arm of the standard position angle theta in quadrant 1. So I've arbitrarily drawn some point AB in quadrant 1. My angle theta is at standard position angle in here, theta. And I've purposely drawn that not at 45 degrees because if we draw things at 45 degrees, it's sometimes hard to infer other things because 45 degrees has symmetry. And there's lots of extra math that's inferred whenever we have symmetry. So I'm going to draw it non-symmetrically. And there's my point AB. It gives me this triangle here. It's got a height of B and a length of A. Now, if I want the expression for cosine of theta minus pi over 2, the first thing I'm going to do is locate where that is. So I've gone backwards 90 degrees, pi over 2. So I'm in that position, that red dot there. Now the triangle is the same, but now it's in different orientation. My horizontal becomes my vertical, and it's going down. My vertical now becomes my horizontal, and it's going across. And I'm not drawing the triangle here, although I could have. I've just drawn it against the y-axis to see a little bit better that this black triangle and this red triangle are the same triangle, and it's based on a 90-degree rotation. And so that gives me a coordinate of B on the x, negative A on the y. So what's happened is A and B have switched. And if I want to write the cosine for that expression, well, I'm going to assume that this is on the unit circle. Actually, I don't know if it was on the unit circle, so I'm going to make this, calculate the radius of this as A squared plus B squared. Okay, so it doesn't say it's on the unit circle, so we're going to say that's A squared plus B squared. And that's that radius, we can then use cosine with that radius. So cosine of theta minus pi over 2, that's going to be that position with the red dot. And so that's going to be the horizontal position of B, or x, divided by the radius, which is A squared plus B squared, square root. So there is expression for that. Now we can do this geometrically like this. In the next unit, there is actually a trig identity that allows us to calculate this a little bit easier.